Yeah, thank you very much. Hi, everyone. My name is Toby Mills. I'm the founder and CEO at Entopy. We're a digital twin company. I've spoken a couple of times on the Gemini Call about some of the projects. The focus of this presentation is very much a use case, so I'm not going to dive too deep into some of the technical aspects. I'm going to talk about how we've deployed digital twin in the maritime sector to provide intelligence across very, very complicated port operations. So we are very, very lucky to be working with our partners, Harwich Haven Authority, at the port of Felixstowe, which is the UK's largest container port, and brings vessels in like the OOCL Felixstowe on screen, which is a Megamax class vessel. So 400 meters long, weighs up to 180,000 tons. So very, very impressive. And the digital twin that we have deployed there is now known as Capella, because we're sort of exploring various ways in which we can sort of take this to the wider maritime sector. The challenge around untangling or optimizing maritime operations is a very, very important one. So global shipping accounts for around 3% of global greenhouse gas emissions. And port congestion is a major, major problem. It's kind of getting worse. And obviously all of these geopolitical events that we're seeing, they really affect ports and shipping and logistics. But the challenge of doing this is really, really difficult, because if you're looking at a vessel, right, we want to optimize its speed. But what are you optimizing against? You're optimizing against the optimal time to arrive at a port, and that's floating. Right, so where we focused our efforts is on the ecosystem, the complex operational ecosystem involved in getting a vessel into a port. And what this will allow us to do, our ultimate goal is just-in-time arrival, right? So if we can optimize this bit, we can communicate with the vessel can arrive just in time, and everything works perfectly. So just for those that don't know, when a vessel arrives, some of these, like I just showed you the enormity of these vessels, right? So it's quite complicated getting one of these vessels to berth at Felixstowe. Vessel arrives, a specialized maritime pilot will board that vessel out at sea and navigate the vessel through its last sort of 10, 15 miles through the local waterways. That pilotage will typically be assisted by tugboats to help with maneuvering. The boat will then berth alongside, containers go on and off, and then the boat departs. Right, that's a really, really simplistic view. That process at a minimum involved 4 stakeholders, and there's like dynamic resource constraints. So this is a super, super complicated problem. We workflowed that, so I'll just talk you through this. So the first one is the boat going to, is the pilotage going to happen, right? Is it going to go ahead as scheduled? So is the vessel going to arrive on time? Is the weather going to be okay? Are there enough tugs? Are there enough pilots? Then you have safe passage. So are the waterways clear for the vessel to berth? Is the destination berth available? This might sound obvious, but if the vessel on berth slips, that berth is no longer available, you have a problem. Is the vessel going to depart on time, right? And is there safe passage? So you can see the kind of concurrency, you can see the knock-on effects. This is like classic, ontology workflow kind of sort of scenario. So the way we've done this is we've essentially looked at each vessel journey as its own unique or distinct digital twin, interacting with the port and various other digital twins. So this is like a gigantic connected digital twin, if you like, that is simplified into a traffic light system. So we have all of these boats, right? And then we basically go along the constraints and we tell you when we think there's a problem. So this vessel's not going to arrive on time. So it's flagging up saying your pilotage is going to move. That helps the tugboats to sort of replan their rest hours. Now, within each one of these vessel journeys, we're predicting lots of different things. When it's going to arrive, how long the pilotage movement's going to be, how many tugs does it need, what time is it going to get into each segment of the channel, because certain parts of the channel you can't pass, so 2 vessels can't be in there at any one time. We're obviously pulling data in from AIS so we can see where it is. So we're predicting its arrival time, its pilotage movement. So that's quite handy to the planners and the operators to kind of know that, especially when they can see that interacting with all of the other vessels that are coming in at the same time. We have a network of AI micro models doing all of this. So this is small statistical models that are predicting various aspects. So this one's predicting the pilotage movement duration. So from the point the pilot boards to the point the vessel bursts, how long is that going to be? This one's predicting ETA. The next one's predicting how many tugs are going to be required. Okay, so right the way across that digital twin, we have very targeted artificial intelligence models predicting very specific things. And then we're looking back in time now to see how we're doing. So you can see the accuracy of these predictions is very, very good. In isolation, completely useless, right? So why on earth would you want to know how long a pilotage is? But you want to know how long the pilotage is when it's played into what part of the channel is it going to be in, how many tugs does it need, how long are those tugs going to be used for. So you can now start to see how these things all start to link together to make something quite powerful. In terms of how this is used, I think one of the advantages we've had with this project is the buy-in that we've had from HHA. They've been absolutely fantastic, and that transfer of domain expertise has been critical. Like, we don't recognize that enough, I don't think, in kind of digital twin communities, but it's so, so important. We define sort of 3 levels of use. So the next 48 hours, so identifying immediate challenges. The next 2 to 7 days, what's going to happen within a sort of time frame where I can realistically communicate with a vessel and ask it to steam slower. And strategic, right? So what happens is that if the Suez Canal reopens tomorrow? What happens if we enable two-way passing, right? Now, the top 2 we can do with classic digital twin. The bottom one, we started to get into lots of problems, right? Well, we've been doing something for a little while, which is putting a large language model onto this. And I've heard this theme kind of playing through. So if you can now imagine a large language model integrating with that digital twin. Problem number 1, we don't have enough time to build countless APIs. So we've had to do, I think you kind of referenced it, but we've got 2 language models basically working together to write and execute code on the DT, which means we can query anything, which is pretty cool. This then has access to the internet, reasoning, various other bits and pieces, and we play that into a product that does this. So you can launch the agent from the software. This is in beta at the moment with the senior team there. And I've been having conversations with the DMV colleagues here about regulating this, which is going to be fun. This bit's chatbot. So this bit's kind of easy, right? So this is just pull some information back from the digital twin. So we're asking for the arrival time of the Everarm. Really straightforward, write me a query, execute it on the digital twin, and that's predictive information. So that information there is coming from micro models. The LLM is not predicting that. Yeah. Next question, how many containers does it have? So this is a future journey, and we're asking questions about what's going to happen. The obvious thing here, if I'm being brutally honest, is what is the point of this, right? Because it's much easier to look at that on a screen, but it's pretty cool. This is where it starts to go into a different dimension. So we've spotted that the Everarm is going to be late departing. I want to understand what the knock-on impact of that is. So now I've engaged the reasoning model, and this is where the regulators are definitely needed, because this is quite powerful. Because what you're going to see, we've sped this up for demo purposes, but this takes about 10 minutes. Goes off and does really, really deep reasoning, and comes back with essentially an answer that says, this is what I think the knock-on impact is going to be. So you can see that it's immediately identified that the OOCL bridge is a problem. It's also identified that this is a deep draft vessel, so it has to sail on the tidal window. So it's plotted out 2 potential challenges. The one is a minor slip, which I think, scenario A, minor slip, it's going to cause some complications. Scenario B, major slip, which is going to cause 12 hours of berth idle time. Very, very significant amount of money associated with berth idle time. And then it prints out some recommended steps in terms of what you can do to mitigate that. So that's kind of the next dimension, I think, of digital twin. But this doesn't work without the digital twin. And I think this makes the digital twin more accessible. Awesome. Thank you very much.
So, Toby, our first question to you, if I could please, is do you leverage any environmental or external data that informs decisions for the ports? Or is this based on just asset performance?
So yes, we do. I think I sort of explained. So we see it as sort of multi-part, right? So the vessel and the digital twin and the environment that the vessel's sailing through, that's part of this. And then we have also modelled the port, and we have modelled or included parameters such as the channel, the waterways. We're obviously looking at tides. We're looking at the environment around it, if that's what the question's angling at, which I think. There is the view to sort of bring surveying data into this, and some of their marine digital twins, the deeper sort of simulation type models that they've got in play as well. So yes, we are already using some of this, and yes, we are planning to expand that.
Toby, question back to yourself, if I could please, from Ali in the room. There's a lot of work globally around maritime automation. For example, Singapore has trialled automated tugs, or autonomous tugs even. Are Entropy connected digital twins built with an eye to this development?
I mean, I think it's a good point. I mean, there's automation in Felixstowe, for example. They've got quite a big automation project. I think it's quite public. So have we built it with that in mind? I don't think that's the reason we're building the digital twins. I think we're building to the challenges that we're seeing now. Do we expect that automation to get rid of the challenges that we're seeing now? No, we think they'll change the challenges. So there's still going to be a resource optimization challenge, even with the automation. There's going to be a part automation, part non-automation period of time. And I think this technology with the automation tools is going to be kind of symbiotic as well. So no, I'm being completely honest. We haven't built it with that in mind, but I think that will probably help